Next speaker will be Professor Uriel Safriel. He is Professor Emeritus of Ecology of the Hebrew University of Jerusalem, Israel, and he has been formerly the Director of Palestine Institute of Desert Research and Chair of the United Nations UNCCD Committee of Science and Technology, which is one of the main bodies in the world to discuss about the consequences of our land use and the climate and other issues which contribute to the agricultural and food production. And Professor Safriel is currently also the chair of Israel National Ecosystem Assessment. So please be welcome.
Okay, thank you very much, Chair. And I want to say first of all that I want to thank the organizers of this conference, the 22nd International Conference on Environmental Indicators, which I have to admit that I did not hear about it before and did not know that it exists. And therefore, in order to prepare at least the title of my presentation, I looked at one of the flyers. And the flyer said, which one is it? This one? Okay, that's good. Yeah. Okay, so this is what the flyer says. This organization is a forum for presentations and discussions on environmental monitoring, protection and maintenance, and their contribution to the ecosystems and our societies. And when I structured this name of my lecture, it is a result of pondering what those who wrote it meant by ecosystems and why these ecosystems need contribution. Now, I think now that if I heard the presentation that we've just heard, just before me, of the Finland representative to the European Union, maybe I wouldn't have any hesitations about this title. And I am very sorry that I could not listen to it before I made this presentation. But now it is too late, and you saved me a lot of time. Nevertheless, maybe I will say something that will actually resonate of what you have said just now. So I thought that I would like to present to you today land as an ecosystem, and to degradation as it's one of its ecosystem states, and the indicators that are required to address this syndrome that is called land degradation. And this syndrome, or this term, has been known to many scientists on Earth now, a lot of them, soil scientists, of course, from very longer time than that. And this started actually with the coming into force of the UN Convention to Combat Desertification. And this convention set to identify or to define land degradation through the term of desertification. So in the text of this convention, there is a definition of desertification that says it means land degradation in drylands. And then it defines land, and they say land means terrestrial bioproductive system that comprise soil and vegetation and other biota, probably they meant this kind of biota, and the ecological processes that operate within the system, like interaction between the soil and the biodiversity, and also other interactions with the climate. So what we have from this definition of land degradation, we see eco at the bottom, system twice, and here it is, this is the ecosystem. And the ecosystem is composed of what? It is composed of biodiversity, which is what is, by the definition of the UNCCP, it is vegetation and biota. Now it is called biodiversity, as we've also heard from the speaker before me. And the interactions with the soil. This comprises what we now call natural capital. This is the capital of what we have. It is like the capital that each of us may have in the bank. Capital that is doing something. It is doing processes. And the processes generate specific processes, like this nutrient cycling that underpins what we call primary production, or primary productivity. And these are beneficial to people. This is what most important. Any ecosystem, all ecosystems are ecosystems, and we call them ecosystems because this is what they are doing. They are doing primary productivity. And then primary productivity is of benefit for people indirectly. Directly, it is through all the other processes that we call, as we have already heard, ecosystem services. So, since the definition originally talks about terrestrial bioproductive system, we are dealing here with land ecosystem. And there are several types of land ecosystems. But what most important for us is to classify the land ecosystems of the globe into two types. On the right-hand side, natural ecosystems. On the left-hand side, ecosystems used by men for the provision of biological products of economic value. And what happens in our world, ever since the agricultural revolution 10,000 years ago, is that this one on the left provide us with food, forage, fiber, wood, which we call provisioning services, and the one on the right, these services, entirely different. Water regulation, soil erosion regulation, climate regulation, pest regulation, pollination, and others. And what we do in our world, we develop the world. How we develop it? We develop it by ecosystem transformation. We transform natural ecosystems to ecosystems used by men, like cultivation ecosystems and grazing ecosystem, grazeland. And when we transform the ecosystems, this is always linked to trade-off of ecosystem services, to the trade-off of regulating services by provisioning services. So what I give to you is some conceptual framework of degradation as something in the context of biodiversity and ecosystem services. So here is the real land. On the right-hand side, you see there's a lot of what we call agricultural land, and we should call it currently used ecosystems. Why currently? Because before there have been natural ecosystems, that part of them has gone transformation into cultivated ecosystems. And this we call development. Now, not all the natural ecosystems were here in this landscape transformed to cultivated ecosystems, because there is also a remaining natural ecosystems that continue to generate the flow of these regulating ecosystem services. And these services are supporting the processes of provisioning in the transformed, cultivated ecosystems. and therefore they can provide sufficient, probably, their product, which is a biological product of economic value, depends for what they are doing it, and we can call it sustainable system. However, as we have heard, as we know, things change on Earth, population is increasing, demands per capita increasing, and then transformation is added. And when transformation is added, it is always added at the expense of the natural ones. So what happens now? This extended cultivated ecosystem requires a higher flow of ecosystem services to support it. But it can get now a reduced flow because now there is less natural ecosystem area. So the service decreases, and therefore also eventually the biological product of economic value decreases unless we do some drastic things that have a lot of what we call external effects. So it seems that somewhere there must be a red line in this rectangle in the middle. That while we are within this red line, we can say that our development is sustainable. And once we cross this red line, as happened when population increased to a certain level, then the development is non-sustainable. The challenge is to know where is this red line. And we can say, of course, but we're saying nothing, that this red line is where the ability of the remaining natural ecosystems to support the transformed ecosystem expired. But we don't know where it is. But the lesson from what I've told you until now is that productivity loss, in this case, what I showed you here, is not due to non-sustainable use of the transformed ecosystem. It is due to non-sustainable development of the whole area beyond the local activities. So the norm that we have on Earth now, and through several decades already in the century, that there is constant land ecosystem change. And what is the indicator for this change? The best indicator is the size or the flow of the biological product of economic value, because this is what we can see on our table, what comes there. So we need to know why it happens. It means, what are the drivers of this land ecosystem change? And the driver that I've shown you now, we can call it ecosystem transformation. This is the driver, but maybe it is the driver of the land use of the ecosystem that has been transformed already. So here's all the framework that I've showed you until now. This is taken from the recently new intergovernmental platform on biodiversity and ecosystem services, IPBS. And what we now need to add to it is the drivers of change. They are biophysicals. Land use change means we change the soil, we change the biodiversity, and the result is that, of course, we change the flow of the interest of this natural capital. And then, in case it was just transformation, we are in the natural land ecosystem. But if it is a degrading use, the change, then we are in the agricultural land ecosystem, and this ecosystem is degraded. This is what we say, it is degraded. So why do we do these biophysical changes? Because these are driven by other drivers of change. People, their policies, their culture, their economy. And these altogether are called indirect changes because they drive the direct changes. And furthermore, since there is human on top, therefore, it depends very much on the component of human well-being, on the health of the community, on their economy, on the social, not necessarily only the community, of regional, global policies, whatever it is, you have now the whole circle of the Biodiversity and Ecosystem Service framework, and in this way we can address better land degradation in this context. And this is what I'm going to do now. So first of all, we can ask what the UNCCD defined, how it defined land degradation, and it says it means reduction or loss of biological or economic productivity in drylands, and here are the drylands. Whatever is not white is drylands, and you see different colors of drylands, it is different dryness. So it is 40% of the global land, if we exclude Antarctica. And what is the common denominator of all different drylands that they differ here in their color? It is that biological productivity is limited by water. Of course, biological productivity requires a lot of things, but it is limited by water. And it's controlled by water, it is regulated by water. So what we see here is the mean of the productivity per year of one of the whole drylands in the world. And you see, and you can see that it is very low as compared to the opposite, the forest productivity, which is one of the most productive ecosystem of the globe. And what is now more important is that if we look at population growth, at least in one decade that when it was done, it is highest in the drylands than in most other ecosystems on Earth. And now this is the issue, this is the problem. People here live in an area that naturally it has low productivity, but the population growth is very high. So the reason of what they're doing, they try to get from the land that does not have a potential to do more than it does, so the productivity increases, but not sustainably, only temporarily. And then it goes down, and when it goes down, it does not return to where was the potential, but further down. So this is actually this is the land degradation in drylands. This is desertification. And now we want to see what is actually the mechanism of desertification. You see here the area, this area has been rangeland. It was overgrazed, overcut. This caused vegetation cover removal, and this causes this soil erosion that you see, and a lot of parts of nutrients that go down that you don't see. And what the land user usually is doing under these circumstances, then this is deserted and becomes, because of the reduced productivity, cultivated. You see the plow sign. But even this is a problem because, especially in drylands, it requires more water than can be available there. And usually then it is traditional irrigation that causes soil salinization, also reduced productivity, and the outcome is, as you can see, the outcome is poverty of the land users, migration, refugees, conflicts, whatever. What are the drivers? The drivers are here. The overgrazing, the direct ones. The overcutting, the irrigation, these are the drivers. So what? The land users don't know what they're doing? They don't have means to do? No, they know what they're doing. But they depend not on themselves usually, but on those who make the policy of land use, economy, demography, and so forth. So we can say anyway that desertification, its mechanism, is a degrading use. And we explain here what is degrading use. So how much desertification there is in the drylands? Everything here that is not gray is drylands, but everything that is the more yellow and even more red is the degree of degradation. And it is currently, there are several assessments, and this is an issue to assess it, but anyway, common knowledge now, it says about 23% of drylands, excluding the desert, because deserts is not in the talk, is already degraded. And what is more alarming is that between 4% to 10% of the potential productivity, not the area, is being lost in this decade of 81 to 2003, newly degraded land constantly. And this is what is important. And when we look at this, for example, I chose this area, you will immediately understand why, this area of degradation or of desertification, and I inflate it, and this is what is called the Fertile Crescent. So what we see, the area that was called Fertile Crescent until today, then it is actually desertification crescent. And this area is the cradle of agriculture of the old world, about 10,000 years ago, and it is in use until today. So we can ask why we have this 4 to 10% loss in these decades, and even in the current decades, we already know that this continues to happen. Maybe the land is exhausted to work for us 10,000 years. Okay, this is just something that somebody can say, but it is not very well based. But it actually tells us, because so many efforts have been to stop this process, and it still continues, that this indicates that we cannot totally arrest desertification. It is going to live with us. It is not achievable. We start with doing something with natural land. There is always a risk of degradation. Or we can say, okay, why didn't we have the United Nations Convention on Desertification? What did it do? Maybe this convention is a failed convention. For example, you just have to see the name of the convention, the full name, then you understand why it failed. If you have a convention that is called that it is combating desertification only in those countries that experiencing only serious drought and or desertification, and particularly in Africa, this is not what the other two, what we call the Rio conventions or the environmental conventions of the UN, with the Biodiversity Convention, the Climate Convention, that do not have these limitations of geography and of process. And therefore they call now that the UNCCD, United Nations Convention to Combat Desertification, is an orphan sister. It doesn't have money, it has no good results. So, and beside this, people gradually learn that land degradation is not limited to drylands. It is global, also out of the drylands. So, the second executive secretary of this convention came into power in 2007. In spite of being being African, he took the UNCCD out of Africa and out of the drylands and out of combating desertification, and he invented something new that is a focused target, but according to aspiration, tangible. Land degradation neutrality. And this was not ratified by his convention, because you cannot get consensus there. It was ratified by the United Nations General Assembly in September 2015 in the process of Sustainable Development Goal that replaced the Millennium Sustainable Development until 2015. And now we have the Sustainable Development Goal number 15.3 that says by 2030, not very long from now, restore degraded land and strive to achieve a land degradation neutral world. What do they mean by that? They call it for short land degradation neutral world. They call it now land degradation neutrality. And they say like this: there are two ecosystem phases of land ecosystem: degraded, as you see here, and the one that in a process of being degraded, what you will see on the right-hand side. For looking on the left, you don't have to be an expert. But looking on the right, you need to be an expert and identify this land as being degraded right now. See, it has land under degrading use, and why? Because it is under degrading use, it is going to be in time already degraded, which means abundant or of a persistently low productivity. So, what we can do? Of course, we have been told by the UNCCD, We have to invest in reducing the rate of degrading land, of degrading use. But the UNCCD is in force since 1996. This land degradation neutrality came 2 years ago. And so far of UNCCD, this is admitted, success is low, insufficient, but what can be done, this is that is being degraded, can be offsetted by the one that is already degraded. So we have to invest in restoring land that has been already degraded. Why we have to do that? This is expensive. This is more expensive than not to degrade. But why should we go there? Because we know that what we do for not to degrade does not succeed. It continues to be degraded. So this means that we don't want to give up land that had a potential productivity, which means it could be productive. The degradation was lost by use. So maybe we should go and try to restore it. Why? It is important, as we have heard before me, the amount of non-degraded land decreases because of degradation every year, and the demand for non-degraded land to become food also increases. And what we want to achieve is not very far off. We're not very ambitious. We say we want only that the amount of non-degraded land that we have now will remain stable, that it will not change. The land will change, somewhere it will be degraded, in other place we restore the same amount that has been degraded. So this is what it means, land degradation neutrality. And if I look at the areas that I showed you just before, both these areas are belonging to this community. The landscape around them, it is their domain. And if they are going to initiate a project of land degradation neutrality, of their domain degradation neutrality, then they know that they have to anticipate that if they continue to lose the land, it will be all the time newly degraded area. But they have to plan something new, to plan for restoring the already degraded land, and therefore to reach the balance, as you see it at the bottom, to reach the balance that there is loss, but no net loss. So this is again land degradation neutrality, and there is now a set of activities. What do you do if you want to get into such a project? So you start with determining your domain, you set the degradation indicators, the most important thing. You use them for classifying 3 land states: the not degraded, the degraded, the degrading use, and then assess the degree of degradation, and then prioritize and also prescribe what you are going to do. And here you can prescribe what you do with the degrading use to evaluate what restoration option you will implement. And then you set a monitoring scheme to know in milestones, in time, when, where, what is your distance from the neutrality of your area, of your domain. Now, setting degrading indicators, it is very easy to write on the slide, but we need to distinguish between fast-changing variables that we use as indicators, that like net primary productivity is fast-changing, crop yield is fast-changing, but underlying of these are the slow-changing variables, like that are indicators also, but reduced carbon stocks, loss of soil nutrients. And we also need to detect the behavior of the ecosystem. If there are non-linearities, like tipping points and things like this, if there are some windows of opportunity to do this thing and not that thing, and some risk again to do this thing and not this thing, and therefore this will be able to teach us how to prioritize and what to prescribe. And it is also difficult to distinguish between degraded and degrading, and it is difficult to measure reducing degrading use and to measure the restoring. The measures are for this are not exactly the same, and we need to distinguish between them. Anyway, the current executive secretary of the UNCCD, Monique Barbour, 2013, getting into position, and she took countries from the 5 UN geopolitical blocks. All these countries, about 14 countries, that set, with her support, set to do land degradation neutral for the whole country. And they identified all degraded lands in their countries, and they are investing right now in restoring, trying to restore all of them. This is something very ambitious, but especially because the indicators are the indicators that have been agreed by the UNCCD after 15 years, agreed on 3 indicators: land use, change, land productivity, and soil organic carbon. So these are the 3 indicators for doing this project. To invest, how do you invest? The idea is that the land degradation neutrality itself is a profitable project. It will do what is written here, number 2, income from sustainable production contracted to national and international producers, additional income stream from the restoration credits, like carbon credits that you can have degradation credits, and then when you get something, you exit and you're returning the upgraded land to the landowners, or you sell the land concessions to new investors. Now, some people that read this agenda were very concerned about production companies, international producers, and selling land concessions to new investors. What about the land users themselves? Are they included in this? This is what is not yet clear. But nevertheless, people say, this is very fast implementation of a new concept, and it may be dangerous for several reasons. Nevertheless, the Science Policy Interface, this is a new body of the UNCCD, already envisaged how the end project report could be filled in. And he said, here it is, I finished the project. This is what I give to the UNCCD to tell them, here, I am done. So, on the left-hand side, you have the ecosystems that are selected to be the domain of the project. And different ecosystems, but they want on the blue ones, that are rangelands. So now, these are the grassland. Let's state what they do. First of all, context, the state T1. They know we have 15,000 hectares of this area. It is under short grazing period, and it is currently not degraded. What are the metrics that you use? What are the indicators? Net primary productivity is this, ton per dry meter per hectare, they measured it. Soil organic carbon, 54, doesn't matter, ton of carbon per hectare. And now, what we decide to do next until T1. T1 will be maybe 3 years from now, 5 years or 10 years, you have to decide. So what we will do, it is under short grazing period, let us increase the period. And then comes T1, they measure again, and they look on the 3 indicators. It is still a grassland. NPP, net primary productivity, went significantly down. That's enough. Therefore, we lost. We have started with 15,000 of non-degraded land. We finished with 15,000 of significantly degraded land. And now we can do all the others. We go through this one, through this one, through this one, and you put gains and losses. The only gains that they can make in this imaginary project report, which of course the project is not started yet, they said only in 3 of them they lost, 1 of them remained with no change, and 1 of them they gained. So when you started with half of the area degraded, half of the area not degraded, and the final result, it is not only the land degradation neutrality, but also 5,000 hectares gain. Okay, so this is nice. This shows what we have in our mind when we are going to set a land degradation neutrality project. But there's one problem, and this is that the changes in productivity are between T0 and T1. But in T0, we don't know if the productivity there is below the potential or it is the potential. And therefore, we need to know this. We need to learn how we can distinguish between a reduction in productivity due to actions of people, of the land users, and between other drivers. So what you do, there is one attempt that I now present to you. Productivity in these things relatively to potential. You have to digitize a map by types of habitat, type of soil, climate, and vegetation type, and distinguish, classify this domain into homogeneous classes. There are 7 or 8 classes. And then you overlay, of course, satellite images with the sensors that you can calculate what is called NDVI, and which is a proxy to NPP. And then the highest productivity that you found in these 10 years in habitat number 1 or in land type number 1 will be 100%. And whatever lower than this 100% is degradation. And degradation in percent, how much degraded. So here it was normalized, the NDVI of 5 years were normalized for 100%. The highest productivity of each habitat is higher 100%. All the parcels that you see here are the habitats, the different habitats. And when it is high green, very strong green, this is the highest MPP of each of the habitats. So when we look here in this area, you see very colors of green, and most of them are close to the potential. So there are different, in this ellipse, there are different productivities, but all of them are the potentials of the different habitats. And this one is the opposite. This is degradation. So here is when we can do, this is called local NPP scaling, this methodology, but it is used on classifying the land use, not the land use, the land types by soil, vegetation, and climate. But climate is a problem, because climate is rainfall. In drylands, it is what determines how much productivity will be there. So what you see here is rainfall in some area between 1996 and 2003, and you see that the productivity, which is in green and in red, follows the rainfall, but there is a difference between the green and the red. The green is not is sustainable, as we know, because we know where it comes from. In both areas, there was the same rainfall, but the productivity was undulating, and we want to know how the productivity is if we factor out the rainfall variability. So this is what we want to do, and this is a little bit complicated. I'll go over it fast. This is rainfall and the graded productivity. So NPP we plot now against rainfall. We got the slope. The slope of this curve, what you see, and there are the residuals. What we really saw are the residuals. The slope is close, it's a proxy for the potential. So there are NPP residuals that are above the curve, and those that are below the curve. And those that are below, those are the negative residuals, they are less than the potential. Above the curve are above the potential, as if. And then what we plot again now is the residuals against time, not against the rainfall. The point of the residuals is the rainfall, and against time. And then we get this regression. So what we see from this regression is, because we see where is the zero, who is below the zero and who is above the zero, then we see that as time advanced in this period, 86 to 2009, more negative residual than positive residuals, and therefore the degradation increased during this studied period, and this is what's important, independent of rainfall. So now we know exactly what people were doing and what to do in order that they will not do it. And here, this is the study area. This is the northern part of South Africa, and you can see the regression slopes. The more the dark it is higher the regression slope, which means more degradation. And the areas that are vertical lines is what is called former homelands. This is the lands of the blacks before apartheid, during apartheid, and therefore it was common land. And what is white is the white farmers that private land. And we know that the degradation trends here are irrespective of rain and rainfall variation, and the direct driver is grazing management. And the livestock density is this, and indicators of degrading use, and they are reduced vegetation cover, changed plant composition, and bush encroachment. Are there other climate effects that we want to factor out? Yes, it is climate change. And here another work of Chinese group 2 years ago, very complicated, and I only give you the highlight. They studied the trends of grassland ecosystems in this decade. And they measure both degradation, and for land degradation neutrality, the restoration of degraded areas. And the drivers of change, of these changes, they found that 49% of the grassland of the world were degraded during that 10 years, and 39% was restored. But what were the drivers? Land use by people, 32% of the 49% was due to what people did. 45% was due what climate change did. And 23% joint activity of climate change and land use. And this is for degradation. What about restoration? Again, 39% due to land use was restored. 31% climate change restored. And then what were there? This is the group is called, started by the person that his name is Gang, but it is Chinese, so it is not what is mean in English. And I'm not going to dwell in it. It is by observation rules of climate effect on productivity, and then the MODIS sensor over NDVI. So, to conclude, placing the land degradation syndrome on the Biodiversity and the Ecosystem Service platform may provide an added value to our action against land degradation. Then I want to say that the drivers of land degradation are not only land use of the cultivated land at the local scale, but what is important, the transformation of natural ecosystem at the larger scale. We have to look at the larger scale first, and then at the local. And then quantifying the effect of land use, what we call, on land degradation. If you want just to attend land degradation without involving it with the climate, we have to factor out the effect of climate variation and climate change. We need to improve our methodologies here, and we have to know or agree when we go to do an LDN project that productivity loss of managed ecosystem is practically inevitable. But feasibility of neutraling it by restoring the lot of degraded land that are already way there and wait for us to do it, they're there. It is worth trying, but it is also we need to be very careful. And finally, everything of this hinges on the credible indicators. We have heard also from my previous speaker, this is the problem. Indicators that are credible and that all the other attributes that are needed to be able to use them and to follow the trends in the change of ecosystems. And there are great knowledge gap in the trends in the behavior of these trends. And this is why we need to do a lot of more things that are very difficult. Thank you very much.
Professor Safriel, thank you very much for this highly interesting and informative talk. And the questions are utterly important since we all live on the surface of Mother Earth. And now our timetable is, or has also been degraded. And so, therefore, I would like to ask for a quick question from the audience. Just one.
Are you optimistic about it? I mean, you described described amazing program and plan. It seems like that people think very much about it all over, the world and US, United Nations and so on. It sounds and it looks so unpractical, impractical. Are you optimistic? Do you think it's going to happen? And just a comment, we already know that governments and other world organizations don't really listen, because facts about global change and CO2 emissions and so on was known for so many years, and apparently people don't really listen. So are you optimistic?
Okay, thank you very much for this question. And I will answer like everybody that is asked a question and give answer on a different question. But regarding one thing, I am optimistic, and this is that I am fully understand that what we have done until now to reduce degradation, we should not continue to do, because it didn't work. And therefore, we have to look for options. And here came a new option. We never heard about it, about land degradation. We heard about offsetting in carbon and in biodiversity. And when this was proposed, it was said, let's look how worked the carbon trading issue and how worked biodiversity trading. There are also these issues. And it works in several states and doesn't work in others. So we are now in the midst of an experiment. This land degradation neutrality project is taken by 14 states. There are 190 states. Let us see what happens. We asked them that it will take 5 years. So I'm optimistic that in these 5 years, an effort will be done, because the government agreed to support the countries, these 14 countries that are doing it.
Thank you.
Thanks to Professor Chill for the excellent question and for the explanation and reply